Okay. Um, Before we verify the properties of the arithmetic mean in Microsoft Excel, it is mandatory to report it in first. So the properties of arithmetic mean can be reported as number first property is the arithmetic mean of a constant c is equal to constant, and the second property is the arithmetic mean or the sum or difference of the two variables is equal to the arithmetic mean. The sum of or difference of their separate mean. The third property is if a constant is added or subtracted with the data whereas any constant it is equal to, it means that mean will also be changed by the same constant. Fourth one, if the variable is multiplied by a constant, then mean will be also changed accordingly. Fifth property is if the data is multiplied by a constant, mean will also be multiplied by the same constant for equality. And last property is if we have k samples n1, n2 up to nk, yields means x1 bar, x2 bar up to xk bar, then the combined arithmetic mean is denoted by x bar c and is defined as x bar c in a combined x bar, this is equal to n1 into x1 bar plus n2 into x2 bar plus up to so on nk into xk bar and divided by n1 plus n2 plus n3 plus up to so on nk. So these are the properties of the arithmetic mean. Now let us verify it in Microsoft Excel. Okay, this is Microsoft Excel data which shows the CGPA of the students. So now let us generate so many variables from, for example, x1 is a variable uh, which is equal to x plus 2, right? And x2 is another variable which is equal to x minus 5, x minus 1, for example. And x3 is another variable such that which is equal to uh, x multiplied by 2, x multiplied by 2, and x4 is another variable which is equal to x divided by, for example, 2. So these are four different variables generated from uh, x. x1 is variable in which a constant is added with the initial variable. This is for one property. x2 is another variable in which a constant is subtracted from the original variable. x3 is another variable in which a constant is multiplied with the original variable. And x4 is another variable in which a constant, the data is divided by a constant, right? So our claim is the mean will also be changed accordingly. So first of all, we need to find out the original mean. Mean mean of the original variable x, and this is equal to average of this data, and the initial average is equal to 3.12. Similarly, the average, first of all, generate these variables equal to x plus 2, and control C, copy, select, and enter. So this is the second variable generated in which 2 is added with all the variables, right? And x2 is another variable such that which is equal to initial variable x less 1. So this is the second variable. The third variable is the initial variable is multiplied by 2. Multiplied by 2. So again, and the fourth variable generated is equal to initial variable is divided by 2. Okay. Now you can find out the arithmetic mean of all these variables. If you copy this arithmetic mean of the column D and press shift and select this area, then you will get the averages of all of the above columns, that is of E, F, G, and H. So clearly these are the means. Okay, now let's verify it. Uh, since we know that if a constant is added with the data, mean will also be changed by the same constant. Equal to, this is the initial mean. If we add a constant 2 with it, it will result into the same mean as 5.12. And clearly this is done, right? Alternatively, at the same time, if you take the initial average, which is this one, and you subtract 1 from it, it will exactly produce an answer which is equal to 2.12. Exactly, this is the same answer, and hence it is verified. Again, here the data is multiplied by 2. So if you multiply the arithmetic mean by 2, you will get the same answer. For example, the arithmetic mean of the original data is this, and steric 2. Again, it is the same answer as 6.25. And if you divide the initial average by 2, because the data has been divided by 2 and its average has been calculated. So if you divide the initial mean by 2, you will get 100% same answer. For example, this is the initial mean and you divide it by, so it is verified. So it means that if you multiply a constant, if you divide a constant, if you add a constant, if you subtract a constant, mean will be changed accordingly. Well, the next property is the sum of deviation of observations from mean is always equal to 0. As we know, the average of this is equal, this column is equal to the average of this, that is equal to this. So if we deviate the average from this data equal to x minus this mean. Press F4 as well from keyboard, F4, enter, Control C, selection of the area, and enter. If you add these values up, it must result into 0. Okay, so sum it equal to sum must equal to 0. Yes, this is 0. This is so because the actual property is, which I missed here, it is, the next property is, the seventh property is the sum of deviation of observations from mean is always equal to 0. So this was actually this property, which simply means that if you find out the means from a specific data and then you subtract that mean from the whole data set, and the net sum must be equal to 0. So this is the seventh property. The eighth property is the sum of the square of deviation of observations in a data from mean is always minimum. It is less than or equal to if you deviate any other value, for example a, from the same variable x, and you square it. So the sum of the square of deviation observations from mean is always minimum. Against, if you deviate any other value than arithmetic mean from the data, you square it and then you sum it. This answer must always be greater than this answer, and we can also verify it in Microsoft Excel. Let's see it. For the next property, let us square it. X minus mean square, x minus mean square equal to, and this is x minus mean. Press shift and 6 per power, shift and 6 per power, and square, we square it, so 2, and this is the square. Control C, press shift, select this area and enter. So this is x minus x bar square, x minus mean square. Alternatively, we have to choose another value against this variable x. So we need to calculate x minus a. A can be any value. Let's suppose a is equal to 3 in this case. I color it. Let's suppose is equal to a, right? And a is equal to 3 in this case, for example. Now, to go for x minus x minus 3, enter, complete this whole column, Control C, Shift, enter. So this is x minus 3. If we square and sum it, its answer will be greater than x minus mean square. So x minus a square, so squaring this value equal to this value to be squared. Shift 6 for power and 2. Enter it, Control C, copy it, select this area and press enter. So this is the, now sum these values up, it will result into, if you sum it, this is equal to 3.8. What about x minus mean square? Its value will be less than x minus a square. Its sum is equal to 3.45. So clearly x minus bar square is equal to 3.45 and x minus a square is equal to 3.8. Hence the property is verified. Now we are going to verify the last property, not the last property, rather property number second property. If you sum two variables or difference two variables, then you find out its mean. It will be equal to the sum or difference of their separate mean. So for this very purpose, let us assume two variables. Well, for now we have two variables. Now we have to verify that if you generate another variable, for example z1 is such that is equal to x minus y, right? And if you generate this variable, this is equal to x minus, enter, and Control C. This is equal to 1. All right. So if you take its average, this is equal to average of this data set. Is equal to this value 1. And if you find out the average, if you copy this over here, you will get the average of this, and you copy it over here, you will get the average of this. So again, if you find the difference will be equal to the average of the x minus the average of the y. Again, this is equal to 1. So clearly this is the variable which is generated as x minus y, and is overall average is equal to 1. Then we did what? We computed the average of x, then that of y, then found the difference. So it means that these are the separate mean. So the difference, the arithmetic mean of the difference of two variables is equal to 1. Similarly, the arithmetic mean of the x and y, the difference of the arithmetic mean of x and y, this is also equal to 1. So this is the proof of the property, which means that if you subtract two variables or if you add two variables and find out its average, it will be just equal to the sum or difference of their separate averages. So this is the verification. We can do the same property by an alternate way. For example, we generate another variable z2 such that which is equal to x plus y. So if we generate another variable, this is equal to x plus and y, and if you find out all the sums, now if you find the average of this equal to average of this sum of x and y, this is equal to 5.25. Alternatively, if you add the two averages up, it will be produce the same answer, equal to the average of x plus the average of y. Again, see, This this value is just equal to this value. For the last property, assume some samples and their respective mean. Assume that we have three samples n1, n2, and n3, right? And mean 1, sorry, yields, this is the samples, and this is their respective means. Suppose the initial sample is equal to 3, the next one is 5, the next one is 8. Sorry. 5 and 7, for example. And N1 results into a mean which is equal to 7, N2 results into a mean which is equal to 8, and N3 results into a mean which is equal to 9, for example. If you want to find out the combined arithmetic mean, C, which means combined arithmetic mean. So by formula, this is equal to bracket n1 into x1 bar plus n2 into x2 bar plus n3 into x3 bar, bracket close, divide by bracket n1 plus n2 plus n3, bracket close, and this is the combined arithmetic mean.